Welcome to Math Prowess. We have Math Olympiad question before us here. The question is 2 to the power of x plus x equal to 5. What there will be the value of x? If you're new here, this is Math Prowess. Subscribe if you've not subscribed, because here we release videos every day. So let's take our solution and go straight to today's business. So take solution. The question is 2 to the power of x plus x equal to 5. So what I'll do at first, I want to move this x to this side of the equation so that 2 to the power of x will stand on its own. So this will now give us 2 to the power of x is equal to 5 minus x. The next thing I will do, I will make the left hand side to be unity. In other words, I want to divide through by whatever I have here. So this is 2 to the power of x all over 2 to the power of x on this other side. So automatically we're going to have 1 on this side. So if I rearrange the equation, I'm going to have here 5 minus x all over 2 to the power of x equal to 1. So from this expression I have here now, because of this numerator here now, I want to do some crazy manipulation here now, okay? So look at what I want to do here now. I want to multiply both sides of this equation by 1 all over 2 to the power of minus 5. So look at it here now. I'm going to have here 5 minus x all over 2 to the power of x times 1 all over 2 to the power of minus 5. Okay, then I do same thing here too. So I have here 2 to the power of minus 5. Okay, so with what I have in here now, I can multiply these two together because they are having the same base. So I'm going to have here 5 minus x all over 2 to the power of x minus 5. Why? Because since the bases are the same and we have a multiplication sign, we can add the powers, right? So with this, we're going to have our left hand side to be your 1 all over your 2 to the power of minus 5. Okay, now this side of the equation, according to the law of indices, this is same thing as 2 to the power of 5. In other words, if I remove this one and this this division sign, then this minus will disappear. And 2 to the power of 5 will give us 32, right? Okay, so we now have 5 minus x all over 2 to the power of x minus 5 equal to 32 as our equation. Rewriting this in an attempt to remove this division sign, so we're going to have this to be 5 minus x, right, in bracket, there times 2 to the power of bracket minus x there plus 5 close bracket equal to 32. Okay, but remember that if we have x, we can equally express this as e to the power of ln of x. Remember, because this and this we cancel out to give us this x back. So if we succumb to this expression we have in here now, we can now rewrite the whole of this expression here. So if we are to rewrite this based on this, then we now have this to be our 5 minus x close bracket, right, there times re to the power of ln of 2 r to the power of, we can move this 5 this way and move this x this way, r to the power of 5 minus x close bracket, everything equal to 32. Okay, again, according to the law of logarithm, we can move this exponent back here, right? Good. So if we do that, then we're going to have here 5 minus x close bracket dot re to the power of 5 minus x close bracket ln of 2, everything equal to 32. So before we can invoke the Lambert W function, we make sure that what we have at these parts must be equal to what we have at the exponent here. So let's multiply both sides by ln of 2. So this now gives us here our ln of 2 bracket 5 minus x there times e to the power of bracket our 5 minus s close bracket ln of 2 equal to, we must multiply this side by ln of 2 also into 32. Okay. All right. Now, according to our product log, it says that if you have a function, like for instance, a star, then times our e to the power of a star, and you take the product log or the Lambert W function, this will give us a star. So if we put this into consideration, look at our expression here now. Here we have something of that kind. Whatever we have at the base is what we have here now. So we can introduce the Lambert W function here. Okay, so if we introduce the Lambert W function here, what becomes of our expression? So we are going to have our expression to be your Lambert W function of bracket open 5 minus x close bracket the ln of 2 the times our e to the power of bracket open 5 minus x close bracket ln of 2. Okay, then let's use the square bracket here. Then everything will be equal to the Lambert W function of 32 ln of 2. Okay, so from here, everything here will now give us our 5 minus x close bracket into our ln of 2 equal to the Lambert W function of our 32 ln of 2 close bracket. So we can divide through by ln of 2 here now. So if we divide here by ln of 2, we equally divide this out by ln of 2. So this leaves the system. So we are now left with 5 minus x is equal to our product log of 32 ln of 2 close bracket all over ln of 2. If we rearrange from here, we're going to have our x will now be equal to our 5 minus the Lambert W function of 32 ln of 2 close bracket all over here ln of 2. So we can rearrange this to give us our x will now be equal to, use this to times this to give us 5 ln of 2 minus the Lambert W function of 32 into ln of 2, then all over ln of 2. Okay, so if you input this into your Wolfram Alpha calculator, it will give you a value. So you can get the value of x from Wolfram Alpha calculator. All right, so this marks the end. So this is the value of our x. Okay, all right, so this marks the end of this Math Olympiad challenge using the product log, otherwise known as the Lambert W function. So thanks for being there. If you've not subscribed, do it to subscribe. And as you subscribe, turn on notification bell so that you get notified whenever we drop an amazing video. Bye for now.